Hey, check out this video.
Wow, it's amazing! I love this video. How is it possible?
Me too. We should try to recreate it.
Yes, let's do it.
Seismic tremors are being studied nowadays for various reasons, especially to prevent damage from them. One way to simplify this natural phenomenon is the vibrating table. The material needed to build a vibrating table are 2 plywood boards, rubber, American tape, silicone, hot glue, 4 springs, a fan, plastic cable ties with holes, and some screws. Constructions begin by cutting the rubber sheets into squares and cut circles in one half of them, with a diameter equal to the diameter of the base of the springs. Then glue 6 of these squares, 3 filled and 3 pierced, for a total of 8 stacks of squares. If desired, you can coat the future outer surface of the 2 wooden boards with the remaining rubber. Glue the rubber stacks into the corner of the boards and reinforce them with American tape. Stick the springs into one of the board and add silicone to the inside of the holes to secure the springs to the rubber pieces. Flip the newly mounted board over the one without springs and repeat the operation. Now let's move on to the fan. Completely disassemble the motor and buttons from its body and then cut off the blades. Fill only half of the empty parts of the inside of the plastic basin with something to act as a counterweight, such as a piece of metal or some hot glue. At this point, 4 holes should be drilled in one of the boards, and the motor should be secured with plastic tape and screws. Unfortunately, however, we found that this method of building the board was not successful. Therefore, we relied on Plan B. Instead of rubber squares, we used plastic ties that we attached to the board with screws, 4 per spring. The fan motor assembly is the same. But what could this tool be used for? Let's look at some applications.
To demonstrate all the different effects that an earthquake can cause to structures, we created different models by using spaghetti and marshmallow. The models differentiate by height and thickness. Generally speaking, shorter buildings are more prone to get damaged by high-frequency earthquakes. Unlike taller buildings, they will tend to be impaired by lower-frequency earthquakes. Propagation waves of an earthquake can have different consequences depending on the type of surface it goes through and in which order. This is the phenomenon of the amplifications.
Soil liquefaction is a ground failure or loss of strength that causes solid soil to behave temporarily as a viscous liquid. Liquefaction takes place when waterlogged sediments at the ground surface lose their strength in response to strong ground shaking. Liquefaction occurring beneath buildings and other structures can cause major damage during earthquakes, but sometimes building sinks while remaining intact. Poorly drained fine-grained soils such as sandy, silty, and gravelly soils are the most susceptible to liquefaction. We created the phenomenon using an earthquake simulator, sand, water, and a building model. We can see that the vibration begins, the building model starts to sink.
The volcano is a very complex geological structure. It's generated in the Earth's crust by the rise-up after an eruptive activity of molten rock mass, the magma, formed under or in the Earth's crust. We tried to recreate a structure the most similar to a real volcano. For doing so, we used the follow-up material: a balloon with a cardboard roll of a toilet paper, a insulating foam, sodium bicarbonate, vinegar and red dye, a cardboard box, cardboard and newspapers, tempera, hot glue, vinegar glue and brushes. Firstly, we filled the cardboard box with foam and we placed an inflated balloon in the center to simulate the magma chamber. Then, to recreate the volcanic vent, we glued the cardboard roll of a toilet paper to the balloon, and with some cardboard and glue, we recreated the conical structure of the volcano. After that, we crumpled up some newspapers and attached them with glue to the cardboard structure to recreate the rocky effect. Later, with some brushes and brown and green tempera paints, we colored the walls to recreate the natural effect. After bursting the balloon with the cutter to create the magma chamber space, we proceeded to carry out the reaction to simulate the volcanic explosion. Adding red dye to the vinegar, we inserted bicarbonate into the magma chamber using a beaker. Finally, the addition of the vinegar caused the reaction.